Hello and welcome to this edition of Stats Chats. Here we're talking about how to conduct a multiple regression analysis. So with a regression analysis, if we're conducting a linear regression involves looking at one independent variable and one dependent variable. And you can think of it as a straight line predicting, seeing if the independent variable predicts the dependent variable. With a multiple regression, you can see in this image that now we have multiple independent variables predicting one dependent variable. So how is multiple regression different from linear regression? Visually, when you look at them side by side, with linear regression, you have one independent variable and one dependent variable. With a multiple regression, we have basically multiple linear regressions, right? We have 3 IVs and 1 DV here. So we can have basically 2 or more independent variables predicting one dependent variable. So if we take multiple regression one step further, with a path analysis, there we're looking at multiple independent variables and one dependent variable, but we're looking at the specific path or progression from linear to multiple, and we're looking at the path that in terms of, I guess, how the literature informs how each of these independent variables help predict or explain that dependent variable. So this is a screenshot from an article by Dr. John Gottman, James Cohn, and colleagues in 1998, predicting marital happiness and stability from newlywed interactions. It was published in the Journal of Marriage and Family. And this is a screenshot of their path analysis. And you can see that this is the path for stable, happy couples. Negative reciprocity, refusing influence, bad and back, and de-escalation are all predictors of positive affect here. So again, path analysis is being able to explain from the literature the path. The path analysis is basically the same thing as regression, but having that explanation for the arrangement of the independent variables from the literature. So for example, John Gottman was able to use the research knowing the connection between negative reciprocity and positive affect, but he and his colleagues wanted to know the influence of other variables that explain the process of the dependent variable, or that explain positive affect within marriage relationships. And this illustrates really the importance of knowing the research literature and how research is important in statistics. This would inform you that de-escalation is linked to positive affect. So Gottman's knowledge of the research literature helped him to identify what variables to include here and how to select those variables. And these are just a couple screenshots from that article that I recommend looking at as a good example of this. But he's got a section on how conflict begins, and it talks about the negative startup model derived from previous literature and how startup is defined as the escalation of conflict from one partner's neutral affect to the other partner's negative affect. And then we also have a little bit more information on negative reciprocity models and power. He cites the literature and laboratories within the US and nationally. So this model is based on extensive literature review. So let's look at one example from a data set that we've been using with our research team that's been looking at attachment-related anxiety and empathy amongst counselors in training. And one of the things that we start off doing, we're doing a multiple regression, is we want to identify what our independent variables or predictive variables are. We want to make sure those are continuous. Remember, continuous variable is interval ratio level of measurement. You can think about a ruler or a scale rather than categorical or categories. So we're going to be looking at attachment-related anxiety or anxiety about our relationships, our close personal relationships, as our dependent variable. And then when we were looking through some of the independent variables, one of the things we saw was that there's a lot of literature linking self-compassion and attachment anxiety. Consider this quote from Moriera's article from 2016 that says specifically higher levels of anxiety were associated with lower self-compassion, which in turn was associated with lower levels of mindful parenting. So self-compassion and attachment-related anxiety, or self-compassion and anxiety, were linked. So we wanted to look at self-compassion as a predictor variable. also mindfulness was a variable we considered. Research consistently supports how higher attachment anxiety and avoidance relate to lower trait mindfulness. According to Stevenson and colleagues 2017, there's a more extensive review, and this quote comes from Jarecki 2021. And then the third variable we looked at was emotional intelligence. In this 2020 study, the researchers indicated that in hierarchical regression analyses, attachment predicted a significant amount of unique variance in both ability and trait emotional intelligence, beyond intelligence and personality. Moreover, attachment anxiety surfaced as the best single, understandably negative, predictor of both emotional intelligences. Their only other mutual predictors being the G factor and conscientiousness. So we can see strong evidence for a link between emotional intelligence and attachment. So we also wanted to look at trait emotional intelligence as one of our independent variables. So once we have our variables selected, independent and dependent, then we're ready to go into SPSS and conduct the multiple regression analysis. So we open our data set, and first we click on Analyze. We click on Analyze, this drop-down menu appears, and we click on Regression. Once we click on Regression, another drop-down menu appears, and we want to click on Linear. Notice, even though we're doing a multiple regression, it's also been called a simultaneous multiple regression, and this is different from hierarchical regression or some other types of regression. One other note about selecting variables, we need to be sure to consider whether our variables, what the conditions of our variables are. So in other words, are we looking at treatment? Are we looking at control? Or are we looking at both treatment and control groups? Also, for our particular data set, we have pre-test and post-test data. So are we interested in looking at pre-test data or post-test data? Or are we wanting to look at an intervention effect and first look at pre-test data and then look at post-test data? So for the purposes of the example I'd like to show you, I'm going to skip down to just discuss the post-test data. For the post-test data, we had wanted to examine the treatment effects, so we first looked at the pre-test data. But in the SPSS output for the post-test data, we could see that the R-squared value was 0.585, indicating that the independent or predictor variables, including post-treatment emotional intelligence total, post-mindfulness total, post-self-compassion scale self-kindness, post-emotional intelligence emotionality, and self-compassion total accounted for 58.5 or 59% of the variance in attachment-related anxiety. The ANOVA table lets us know if our model is good or not. The significance column, the last column, it indicates 0.001. So since the significance level is below 0.05, it indicates that these are good variables to explain attachment-related anxiety. So perhaps going through the interventions that the students went through, because our model at the time of pretest demonstrated that these were not predictors, and the model was not statistically significant, and the variance explained was 0.25. Now this is almost doubled, and it is statistically significant. So something happened to these students at during the intervention, and perhaps they became more emotionally intelligent, more self-compassionate, and less anxious about their attachment relationships. So the ANOVA is testing the model summary table. Our null hypothesis would be that the multiple R, the R squared, is equal to 0. So note, the multiple R is the R squared because multiple independent variables are creating this R squared, which is explained variance in the dependent variable. So since our significance level here is less than 0.01, we would say this is a good model. Now we can look at our coefficients table. We want to look at the SIG column, which is the 1, 2, 3, 4, 5th column from the left. We want to see if any of these significance values are less than 0.05. So as we go down, we can see that self-compassion, self-kindness was 0.01. So this is a statistically significant predictor, as well as trait emotional intelligence emotionality was also a statistically significant predictor, and emotional intelligence total. Trait emotional intelligence total was also a predictor of attachment-related anxiety. So our next step is to write these results up in APA style. And we would say something along the lines of: the researchers investigated the role of self-compassion, total score, self-kindness, total trait emotional intelligence, the emotionality factor of trait emotional intelligence, and mindfulness, to see if these predictor variables explain the treatment effect of empathy training on attachment-related anxiety scores through multiple regression analysis. The explained variance was r squared equals 0.585. So the predictor variables explain 59% of the variance in attachment-related anxiety. The best predictors of attachment-related anxiety were statistically significant. These include emotionality, factor of emotional intelligence, and then we want to insert our p-value that comes from the coefficients table, as well as the beta value. And then we list this for each of the statistically significant items. Now, a couple notes: this cursive B is our beta, what represents our beta value. And if you wanted to know which of those predictors was the best predictor, it would be the highest absolute beta value. So trait emotional intelligence was the best predictor that contributed the most to attachment-related anxiety, followed by emotionality and then self-kindness. The other variables that were not statistically significant and did not really contribute to the dependent variable were post-mindfulness and self-compassion scale total scores. So this is the APA style write-up for the multiple regression analysis. Now, a couple other things to consider when you're looking at the output. You want to look at things like multicollinearity, and you also want to look at things like normality. So the correlations table will tell you about multicollinearity. If there is a correlation above 0.7, we'll want to take a closer look to see if next time we might want to eliminate one of these variables or combine the variables. For example, self-compassion scale total was linked with self-compassion scale mindfulness. Well, the mindfulness scale is part of the total self-compassion scale, so we would expect these to be correlated. So we may decide, okay, in our next analysis, we're just going to look at one of these because of the concerns with multicollinearity. Let's see. So we can also look at the coefficients column to look at collinearity tolerance, as well as variance inflation factor. We want to see if the tolerance is less than 0.1 and that these VIF values need to be above 10. So we also have some concerns here with those values. A residual table is another way of looking at this. In the residuals table, we see Mahal's value, Mahal's distance maximum and minimum value. We can look at a table for Mahal's value, and in a table, if you have 6 variables, which is what we have, 6 independent variables, the critical value is 22.46. And so we can go into the table and see that our value for Mahal's max distance was less than that. So we don't have to worry about outliers. Same thing for Cook's value. So this is just a way of looking at outliers. A couple other things to keep in mind, looking at the charts at the bottom of the output. These charts will give us information about normality. We can see on this chart that these blue dots are really hugging this line. And so this helps us see that this is really seems to follow normality. If these dots are much further away, we might be concerned about normality. Also, another visual check for normality, you want to be sure that the line on the scatter plot is flat. And this line is both close to 0 and flat. So this indicates normality as well. And then we can go back to the coefficients table, and that's where we look at the significance value for our predictors and the beta value for which are the highest predictors. So again, in the APA style write-up, we want to be sure to mention R squared, want to mention our beta values, our p values, whether our model was statistically significant, and our predictors. So I hope that this helps guide you as you work on multiple regression analyses and gives you some concepts to contemplate. Until next time, God bless your work.